Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture, and in this video lecture we will prove these two things, and this video lecture will make use of the properties of forward difference operator that we studied in the last lecture. And this question is important from examination point of view. This is important question. So let us do the first one. The forward difference operator delta a raised to the power cx plus d. Okay, now use the definition forward difference operator. X will be replaced with the next value and h is interval of differencing. So next value will be x plus h. Just next will be this one, and further next will be x plus 2h and so on. Fine. So we are going to use in place of x, because by definition delta fx is equal to f of x plus h minus f of x. So I am going to use it over here. A c instead of x I am going to write x plus h plus d minus f of x, this thing as such, a raised to the power cx plus d. Done. This is further equal to a cx plus ch plus d minus a raised to the power cx plus d. So this is further equal to a raised to the power cx plus d plus ch minus a raised to the power cx plus d. Now this thing could be written as a raised to the power cx plus d, and this could be separated also, a raised to the power ch minus a raised to the power cx plus d. Now what you will do, you will take this one and this thing common, because this is same, this is same, so I am going to take this thing common. So it will be a raised to the power cx plus d, and inside of the braces we are left with a raised to the power ch minus 1. So this implies that delta a raised to the power cx plus d is nothing but a raised to the power cx plus d, and this will be a raised to the power ch minus 1. So this was the first to prove. So next what we need to prove is the second thing, and you are going to name this equation as equation number 1. Now we have to apply, we will prove it by generalization, we will prove it for 2, then we will see the result. Here a raised to the power cx plus d. So this can be written as a raised to the power cx plus d. Fine. And when it is applied one time, so this is the result. So I am going to use equation number 1 delta, and here it can be written as a raised to the power cx plus d a raised to the power ch minus 1. We have studied in the properties of operator, because a delta of c f of x we have studied is equal to c delta f of x. So using this property over here, this whole thing is a constant quantity, this whole thing is constant, so this can be taken outside of the forward difference operator. So this could be written as a raised to the power ch minus 1. It is free from forward difference operator. A raised to the power cx plus d is equal to a raised to the power ch minus 1. Now once again I am applying this one, so the result will be same using 1. Once again using 1, we will get a raised to the power cx plus d into a raised to the power ch minus 1. Okay, once again using 1. Here we have also used using 1. Fine. So you can mention it wherever it is required. Now see here that this is 1, this is 2, so it will be a raised to ch minus 1 whole square. So we can write it as a raised to the power ch minus 1 whole square and a raised to the power cx plus d. Fine. Now look over here, when here is 2, delta square 2, so here is 2. Fine. And when here is delta 1, here is power is 1. Similarly, simple generation, whenever here will be delta 3, here will be 3. When here will be delta, there will be n, delta n. Okay. Similarly, a simple generalization will imply, what will it imply? A raised to delta n a raised to the power cx plus d is equal to a raised to the power ch minus 1 this whole raised to the power n a raised to the power cx plus d, and that is equation number 2. This was the second thing we need to prove, and that we have proved over here. So this is very important result from examination point of view, and it is making use of the properties of the forward difference operator. Fine. Now we'll move towards the next problem. Now this is the next problem. Delta cube, we have to calculate 1 minus x into 1 minus 2x 1 minus 3x, where interval of differencing being unity. So here it is worth to mention that h is given as 1. Fine. So let me calculate this one, and inside is 1 minus x, 1 minus 2x, 1 minus 3x. So this will be, now multiply 1 minus x, this will be 1 minus 5x square plus 6 x square. Done. This will be, now multiply, this one will multiply, it will be 1 minus 5 x square plus 6. Here is, you will make minus 5x plus 6x square. Fine. Now this is further equal to delta cube, this will be 1 minus 5x plus 6x square, minus will multiply minus 5x square minus 6 x cube. Now collect the powers of same degree terms. Okay, so this will be 1 minus 6x plus 11 x square minus 6 x cube, and we know that this forward difference operator is distributive over addition, so it will be delta cube 1 minus delta cube 6x, 6 will come out because we have the property, so delta cube x plus 11 will come out, delta cube x square minus 6 delta cube x cube. Now here see, let me calculate these things one by one. first let me calculate delta cube 1. Otherwise result is that if we have the third degree term and the forward difference operator of the same order will give the constant term, but if the degree term is less than the forward difference order of the forward difference operator, then that will reduce to 0. So ultimately this will reduce to 0 because here the term involved is having degree 1 and forward operator order is 3, so this will reduce to 2, and here term order is 0, so this will reduce to 0. But we will show here also it can be written something like delta square, and when delta applied upon 1, constant term is 0, so this is equal to 0, so this is 0. Otherwise you could also use the result if here degree is 2 and forward difference applied is higher, then that will reduce to 0 obviously. Here degree is same, so we will get some constant term, so with that could give some constant term. Now delta cube x, it will be delta square delta x. Delta square delta x is x plus 1 x plus h minus x, and interval of differencing given here is 1, so this will cancel out, so we are left with delta square 1, so this can be written as delta 1, and forward difference operator of constant quantity is 0, so this is again 0. Fine. Similarly delta cube x square delta x square. Fine. This can be written as delta. Now first delta, when you will apply over here, it will be x plus 1 whole square minus x square. Done. This will be delta, and it will be x square plus 1 plus 2x minus x square. In the examination you have to show it something like that, delta 1 plus 2x. Fine. So this is equal to delta. Now this delta is distributive or addition, delta 1 and 2 will come out, this will be 2 constant quantity, this is also the property delta, and of constant is 0 plus 2, or delta x is x plus 1 minus x to x will cancel out, so we are left with delta 1 which is 0, so this is 0. Now finally we are going to calculate delta cube, so delta cube x cube is equal to, what will do, delta, here is x cube. Fine. So what you will do, you will write delta, now it can be written as x plus 1 cube minus x cube. Fine. So this thing is further equal to delta. Now open the cube, x cube plus 1 plus 3x plus 3x square minus x cube, this will cancel out, so we are left with delta 1 plus 3x plus 3x square. Fine. So this will distribute over it inside, delta 1 plus 3 will come out being a constant quantity, delta of x plus 3 delta x square. Fine. Now we have to find the value of delta x. Here you will look that delta x is nothing but equal to x plus 1 minus x, so this is equal to 1. Fine. Next we need delta x square, we will be needing delta x. So this will be x square. So this will be x plus 1 whole square minus x square. This will be x square plus 1 plus 2x minus x square. This will cancel out, so we are left with 2x plus 1. So I am going to substitute it over here. Delta, this will be delta 1 is 0 plus 3. This value is 1, so 1 plus 3, and this value is 2x plus 1. This is nothing but equal to delta 3 plus 6x plus 3, okay, is equal to delta 6x plus 6. So this will be further equal to delta 6x plus delta 6, and this can be written as 6 delta x plus 0, and delta x you have calculated is 1, so this value is 6. So this implies that delta cube x cube is equal to 6. So by simply doing this calculation you can calculate any term involved. So this is equal to 6. So this implies that this term is having value, this is 0 minus 0 plus 0, and here 6 into 6 will be minus 36. So therefore we have calculated, so let me write it over here. I think here it will be fine. Delta cube 1 minus x 1 minus 2x 1 minus 3x is nothing but equal to minus 36. So this is the evaluation. So this question is very important from examination point of view, and you should go through this question very carefully. So that is all I have from this lecture, and similar question you will attempt at your own, and if you will feel any difficulty you will ask me. So till then, keep studying, keep learning. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.